Hello and welcome to another past paper session. Today we have October-November 2023 5-1. This is an S1 exam. Let's start solving. It says um, the times taken by 120 children to complete a particular puzzle are represented in the cumulative frequency graph. Use a graph to estimate the interquartile range. So the interquartile range is upper quartile minus lower quartile. So let's first do the lower quartile. It's 1/4 of 1/20th. So that's the 30th. So I have to read the 30th value and I have to read the 90th value as well. So let's try to read those from the graph. It's important that you draw these dotted lines on the exam as well to show the examiner what working you've done. So reading this was somewhere between 24, 23 and 24. So I'm going to say it's somewhere between 23 and 24. I can figure that out in a bit. And this one falls 90th. 90th is here. This one falls exactly in 31. So that's 31, that's done. For this, I will take a number and let's call that 23.7. The marking scheme also does that. So make sure that you do as accurate an approximation as you can. And the answer is 7.3. Yeah. Okay. 35% children took longer than t seconds. So 35% of 120 is 42. So 42 children took longer than t seconds to complete the puzzle. So I need a number that has 42 children above it. Now, if you do this, you're doing it wrong. Why? Because you're then saying that there are not 35% people above it. There are lots of other people above it. There are about 65% people above it. So this question is about the top 42. So I'm going to subtract 42 and say that 120 minus 42 gives me 78. So I'm going to read the 78th. 78th comes out somewhere here. And this is also falling between 28 and 29, I think. So I can go with 28.5. Going on to question two, it says Azim repeatedly throws two ordinary fair six-sided die at the same time. On each occasion, the score is the sum of the two numbers that she obtains. Find the probability that it takes exactly 5 throws of the two dice for Azim to obtain a score of 8 or more. Now I can do this and find out 8 or more. How many occurrences of 8 or more? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So 8 or more would be 6 and 2 is 8. Let's just put tick marks. 5, 3, and 5, 6, 3, 4, 4. So lots of outcomes actually. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's 15 out of 36. So that's my success on one throw. Find the probability that it takes exactly 5 throws of the two dice for Azim to obtain a score of 6 or more, 8 or more. So this is about a geometric. And on each term, my probability of success is 15 over 36. Okay, Q should then be 21 over 36. So what is the probability of exactly 5 throws? I'm going to say Q power R minus 1 and P power 1. Okay, let's check if that is the right answer. Yes, that is indeed the right answer. And I should be getting 12005 over 248832, which is 0.0482. Okay, so I know it's geometric because then I'm not talking about how many successes in those 5 turns. I'm just saying I want to be successful on the 5th turn. Find the probability that it takes no more than 4 throws. No more than 4 throws. of the two dice to obtain. So I'm asking you for the probability of x less than or equals to 4. So less than or equals to is simply 1 minus q power r. So 1 minus 21 over 36 power 4. I hope that should give me the correct answer as well. That is giving me 0.884, and that is the correct answer. For 8 randomly chosen throws, now I'm giving you a trial and error. A number of trials basically. Find the probability that Hazim obtains a score on 8 or more on fewer than 3 occasions. So I have a total of 8 trials, and I want on fewer than 3 occasions. So I'm asking you for the probability of 2, 1, and 0. Why? Because now it's a binomial. I fixed the number of trials. I'm going to say 8c2 q power n minus r p power r plus 8c1 8 minus 1 power 1 8c2 8c0 8 minus 0 power 0. Okay, let's put that on our calculator. I think I'm going to use my calculator to do that directly. I'm going to accumulate a binomial, till 2, n is 8 and p is 15 divided by 36. I am getting 0.282. That is the correct answer. Yeah, that is indeed the correct answer. Moving on to the next question, I have a farmer sells eggs. The weights in grams of the eggs can be modeled by a normal distribution. So this is a normal distribution question with mean equals to 80.5 and standard deviation as 6.6. Eggs are classified as small, medium, or large according to their weight. A small egg weighs less than 76 grams, and 40% of these are medium. Okay. Find the percentage eggs that are classified as small. So I'm asking you to calculate the probability of the small eggs and then convert that to a percentage. So z is less than 76 minus 80.5 divided by 6.6. 76 minus 80.5. I am getting probability of z less than minus 0.682. So that's pi of minus 0.682 and 1 minus phi of 0.682. So let's read 0.682 from our table. Just checking if I have the correct number. Point 0.68 and 2. So 7524 against 0.7524. 0.2476. Okay, so 24.76% or 24.8% of the eggs are classified as small. Moving on to the next question, find the least possible weight of an egg classified as large. Now, 40% are classified as medium. So what should be the large percentage? Large percentage should be 100 minus 40% minus 24.76%. Okay, so 100 minus 40 minus 24.76. So that gives me 35.24. So probability of x greater than a number large is 35.24%. So I'm going to use my normal distribution again and say that z is greater than L minus 80.5 divided by 6.6, 0.3524, 1 minus phi of L minus 80.5. So 1 minus 0.3524 equals to phi of L minus 80.5 over 6.6. Point 6476. Okay, so I then have phi inverse of 0.6476 equals to N minus 80.5 over 6.6. Now I can do this on 0.6476. Let's do that from the table only, since most of you will have the table. I have 6443, 6476, 6476 minus 6443 gives me 33. I need to add 33. So I'm going to add 34 and say that this should be 0.37 and 9, I think. We've rounded off a little. I don't know what my calculator will give me. I am hoping that would be correct as well. 6476. 0.3788. 379 should be the right answer. 0.379. 0.379. Okay. 0.379, 6.6 plus 80.5. L equals to 83. Okay. Since the decimal isn't causing any trouble, that should be the answer. 150 of the x. So this is a trial. Or this for sales last week were weight. Use an approximation to find the probability. So when it says use an approximation, this is about binomial to normal. I want to calculate the probability of more than 68 of these eggs. So the first thing that you need to do is do continuity correction. Okay, for continuity correction, you can say that this is going to become 68.5, since the first number that I want is 69 and then onwards. So that's that. Do we have mean and variance? Let's think. Mean is NP. So 150 into what is my success? I want classified as medium. So zero point 0.4, 40%. So that's 60, I think. Okay, and variance is NPQ. So 60, 150 into zero point 0.4 into zero point 0.6 gives me 36. So probability of z less than 68.5 minus 60 divided by root of 36. One point four one nine two one seven. 0.0783. Let's check. Yes, that is the right answer. Moving on to the next question. Question number 4 says the times to the nearest minute of 150. Athletes taking part in a charity run are recorded. The results are summarized in the table. Draw a histogram. So the first thing that you should do is you should connect these 120.5 and 100.5, and then 130.5, and then 135.5, and 145.5, and 160.5. Okay. The class width is going to be 20, 10, 5, 10, and 15. Frequency density will be frequency divided by class width. So 18 divided by 20 gives me 0.9, 4.8, 6.8, 3.2, and 18 divided by 15 is 1.2. Okay, I hope my frequencies are densities are correct. Then what I'm going to do is I'm going to start making a sketch and say that I will have a jagged line here because my axis will not be starting from 100. Okay, a jagged line here, and let's start that from 100. 120. Where do I have to go? 160. So let's call that 110, 120, 130, 140, 150, 160. And what are those? Those are time in minutes, and this is frequency density. I have to go up to 6.8. So just let's write down 1, 2, 3, 4, 5, 6, 7. Okay. The first line starts from 100.5 and goes on to 120.5, and it has a frequency density of 0.9. So I'm going to draw it at somewhere here and somewhere here. Say that that's my first bar. Okay. Then from 120.5 to 130.5, and I want to go 4.8. So let's stretch this to 4.8. Okay. Um, then 135.5, and I have 6.8. It's as accurate as I can make it. Then 3.2, go up to 145.5. And then the last one has 160.5 and 1.2. Okay, that is what your histogram should look like. Mean and standard deviation of the times the athletes take. So I'm going to have to calculate the midpoints then. So my midpoints will be the midpoint of 100.5 and 120.5. That gives me 101 plus 120 divided by 2, 110.5 for the first one. What is its frequency? Its frequency is 18. So I'm going to write that. The next midpoint that I have is 120, 125.5, and the frequency I have is 48, 34, 32, and 18. 48, 32, 34, 32, and 18. Okay, and 131 plus 135 divided by 2, that gives me this is 133, 140.5 as a midpoint, 133 and 140.5, 133 and 145. On the exam, you should do this so that you don't make a silly mistake. It's taking me long, but that is the ideal way of doing it. 153. Now that I have everything in front of me, I can do mean is equals to sum of fx divided by sum of f. Let's calculate 110.5 into 18 plus 120.5.5 into 48 plus 133 into 34. Important to also type it carefully. I have 19785 divided by how many athletes? 150 athletes. Divided by 150. Yeah, I'm getting 131.9 for the variance, and then the standard deviation you're going to do sum of fx squared over sum of f minus the mean squared. Okay, so let's quickly square and multiply. It's a bigger number, 2630272.5 over 150 minus 131.9 squared. 137.54. Take the root of that to get standard deviation, and that should be 11.7. Okay, moving on to the next one. A red spinner has four sides labeled 1, 2, 3, 4. When the spinner is spun, the score is the number on the side on which it lands. The random variable x denotes the score. The probability distribution for this is given. Show that this is that. So 0.28 plus p plus 2p plus 3p should equal 1. So that's 6p equals to 1 minus 0.28. P equals to 0.72 divided by 6, and that should be 0.12. A fair blue spinner and a fair green spinner each have four sides labeled 1, 2, 3, 4. All three spinners, red, blue, and green, are spun at the same time. Find the probability that the sum of the scores is 4 or less. Now, I can't have a diagram for three things together. So what I'm going to do is I'm going to write red, blue, and green and see what the scores come out to be. And then I'm going to calculate the probability as well. So that's what I'm going to do. Um, So red, let's say I want 4 or less. So I'm going to start with the lowest score possible. I'm going to say that I'm getting 111. Okay, that's a total score of 3. Okay, so the two scores can be is 4 or less. So it can either be 2 or it can either be 3 or it can be 4. Okay, so 111. Then I keep this as 1. I change this to 2, and this should be 1. So that's a total score of 4. So those are all the possibilities. Let's first change that one so that it becomes standard. Okay, then I can have 121 or I can have 211. Okay, so what's the probability of getting a 1 on the red die? It's given here, so that's 0.28, and the other two are fair, so it's going to be 1/4 into 1/4. Then 0.28 again into 1/4 into 1/4. 0.28 again into 1/4 into 1/4. Why? Because the other two are fair. What is the probability of getting a 2? It's 0.12. So 0.12 into 1/4 into 1/4. Okay, all of this gives me, I can calculate the total and it should give me 0.06 at the end. Okay, find the probability that the product of the three scores is 4 or less given that x is odd. Okay, remember that x is the number on the red die. So red, blue, and green. Find the probability that the product of the three scores is 4 or less given that x is odd. Okay, since it says given that, I know that given that is the probability in the denominator. What is the probability of x is odd in the denominator? I can say that the probability of x is odd in the denominator is the probability of 1 and the probability of 3 here. So it's 0.28 plus 0.24. So that gives you a total of 0.52 in the denominator. Now, For the numerator, you have to say that 4 or less and x is odd. So I will have to come up with a series of, like I created one for the sum. I will have to create one for product as well. So let's say R is 1. Okay. Um, Blue would be 1 and green could be 1 and the product will be 1. Okay. When R is 1, blue is 1, the green is 2, the product is 2. Okay. When 1, 1 and 3, the product is 3. Okay. 1, 1, 4, the product is 4 or less, so that also meets the criteria. Then I should change the second number now. I should say 1, 2, 1, the product is 2, it's less than 4. 1, 2, 2, the product is 4. Okay. I could also have 1, 3, 1, the product is 3. I could not have 1, 3, 2, 1, 4, 1, and the product is 4. Those are all the possibilities with R being 1. For the next one, I have R as 3. So this could be 1 and this could be 1. So 3, 1, 1 gives me 3. Okay, and then I could have, I think, no others. Okay, those are all the outcomes that I have. If I want to calculate the probability of this one, I'm going to say that this is 0.28 as was given here. And then since blue and green are unbiased, so 1/4 and 1/4. So that's 0.28, 0.28, 0.28, 0.28. So a lot of 0.28s, and then 1/4, 1/4, 1/4. All of these are also identical. Okay, this is also identical. So how many of these do I have? I have, I think, 8 of these. Okay, I have 8 of these, so I can say 8 times 0.28 into 1/4 into 1/4 plus, what's the probability of 3? The probability of 3 is 2p, which is 2 times p, which is 0.24, and then that's 1/4 and 1/4. So 0.24 into 1/4 into 1/4. Okay, that should serve as my numerator. Let's check if we have the right answer. I have 31 over 200, which is 0.155. Is that the correct answer? Yes, that is indeed the correct answer, and I have a total probability of 0.298. Okay, moving on to the next question now. This is permutations and combinations. Okay, 6 people. Question 6. In a restaurant, tables are rectangular, two along each of the longer sides. 8 friends have booked 2 tables, X and Y, Rajat, Sue, and Tan. Are 3 of the friends. The 8 friends will be divided into 2 groups of 4, one group for table X, one group for table Y. Find the number of ways in which this can be done if Rajat and Sue must sit at the same table as each other, and Tan must sit at the other table. So first, let's assume that Rajat and Sue are in S are at table X. Okay. Um, and you just want to divide into groups. So right now you're not arranging them. So how many people tan then must be on T must be on Y? Okay. Okay. T must be on Y. Okay. So if Rajat and Sue are here, how many people? There are 2 seats remaining, and there are 5 people remaining since tan must be on Y. So 5C2 into 3C3. Okay, that is what you would have for the first one. If R and S are at table X, then R and S are at table Y, and T must be at X. So again, for table Y, um, I'm going to say that that's 5C2 into again 3C3. So I'm going to add these 2 conditions and say that 5C2 is 10, 10 plus 10 is 20. So I get a total of 20. Then When the friends arrive at the restaurant, rather than so now decide to sit at table X, so they are on X now, on the same side as each other. So either they can sit on this side or downwards or upwards. Let's call that that. Dan doesn't mind, decides that he does not mind at which table he sits, and the number of different seating arrangements for the 8 friends. So you must first decide that they are on table X and they are on this side of the table. Okay, but they can switch between themselves. So let's just write 2 factorial right on the go. Uh, and they are sitting on, rather than Sue are sitting on this side. How many seats are there? There are 2 seats and no one else minds where they sit. So there are 6 people deciding if they want to sit with rather than Sue. And then those 2 people can also arrange themselves. For the rest of the people, they go to table Y and they seat themselves. Arrangements. Now it's arrangements. It's not just dividing into groups. Okay. Uh, Plus, if Rajan and Sue were sitting on this side of the table, okay, again they could switch between themselves. There are other people who want to sit here, uh, uh, and they can arrange themselves as well. And then other people on the other table can also shuffle around between themselves. I don't know if this is going to give me the correct answer, but let me just try. 2 into 6c2 into 2 into 4 factorial into 2. Yeah, so that gives me a total of 2880. So I've decided I want to have separate cases for rather than so sitting on different sides. Then as they leave the restaurant, the 8 friends stand in a straight line for a photograph and the number of different arrangements if rather than so stand next to each other. So they stand in a box, uh, but neither is at the end of the line. Okay, so neither is at the end of the line. So there are 6 other people. So 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, and 8. Okay, so Raj and Su could be standing here, or they 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 could be standing. No, those are the 4 things that they could be doing. 3, 4, 5, 6, 7. I think I've missed one case. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, I've messed up a dash in the middle because so there could be another case. Okay, for each of these cases, Rajadans who could shuffle between themselves, and the rest of the 1, 2, 3, 4, 5, 6 people could arrange themselves. How many such cases are there? There are 5 such cases. So I'm going to say 5 times 2 factorial into 6 factorial. That's the easy way of thinking about this question. 7200. That is the correct answer. That brings us to the end of today's exam. I will be back with the next video for the next paper. Thank you for watching.